What's the role of Kubernetes and Kubeflow in AI systems? Kubernetes is the orchestration engine that keeps containers running across a whole cluster, like a control tower, assigning every plane to the right runway and checking that each one stays safely in the air. It doesn't understand machine learning. It only ensures containers stay alive, scale when needed, and run on the right nodes, even when you're using 20 or 50 GPU machines. Kubeflow then builds on this foundation by adding ML-specific workflows through CRDs, which are like new verbs Kubernetes learns, so it can run training jobs, pipelines, and serving systems cleanly. Think of Kubernetes as the road system and Kubeflow as the specialized trucks that know how to deliver ML jobs. A common mistake is believing Docker alone can scale across machines, but only Kubernetes provides distributed orchestration. In an interview, a strong answer is Kubernetes manages cluster state. Kubeflow provides ML workflows on top. A likely follow-up is when to use both, and you can say, whenever you want portable, reproducible AI that behaves consistently across clouds. Don't worry if this feels abstract. Once you imagine infrastructure as the roads and Kubeflow as the delivery system, the relationship becomes natural. Understanding the stack. Kubernetes works like a distributed scheduler combined with a reconciliation engine, always checking whether the actual cluster matches the desired state. The way a smart city grid constantly adjusts traffic lights to keep cars moving. When training on large clusters, 8, 16, or even 64 A100 GPUs, Kubernetes places pod based on resource requests, but not GPU topology, which is why ML operators add the missing intelligence. Kubeflow extends Kubernetes by introducing CRDs like TFJobs, PyTorchJobs, and Pipeline Run, which teach Kubernetes how to launch multi-worker training jobs or DAG-based pre-processing steps, similar to adding dedicated rail lines so a city can run specialized trains. A common mistake is thinking Kubeflow replaces Kubernetes, but it only augments it. Kubernetes still performs scheduling, scaling, and health checks. So, in an interview, a strong answer is Kubernetes is the infrastructure layer. Kubeflow adds ML-specific abstractions through CRDs. A likely follow-up is why this layering matters, and you can say, it separates infrastructure concerns from ML concerns so each team can move independently. Let this settle in. Once you picture Kubernetes as the operating base and Kubeflow as the ML toolkit installed on top, everything lines up cleanly. Real-world ML workflow. Let's slow down and walk through the ML workflow like a factory assembly line, where every station has a specialized role. Data ingestion begins with Kubernetes orchestrating storage volumes, CSI drivers, or object stores like S3 or GCS, which may deliver hundreds of gigabytes per second during large vision or LLM training. Preprocessing uses Kubeflow pipelines to orchestrate containers you define. Think sous chefs cleaning ingredients before the main dish. Training is where Kubeflow's PyTorchJobs, TFJobs, or PyTorchJobs coordinate workers and synchronize gradients through NCCL, like every GPU passing notes around a circle at hundreds of gigabits per second. Kubernetes simply schedules the pods. Kubeflow understands the ML job roles. A common mistake is assuming Kubernetes knows how to run distributed training. It doesn't. Kubeflow's operators handle coordination. Deployment then uses Kubernetes for scaling and Kubeflow for versioning, so you can roll back cleanly when drift appears. Monitoring blends Kubernetes metrics with tools like Prometheus or Grafana for throughput, latency, and accuracy over time. In an interview, A strong answer is ML workflows become reproducible because every stage is containerized and orchestrated as a DAG. A follow-up might be how DAGs help, and you can say each step is isolated, predictable, and repeatable, like stations on a factory line. You're building a deep mental map now, and that's exactly the goal. Common follow-up questions. Let's walk through questions interviewers ask constantly. Docker runs a single container, but Kubernetes orchestrates many containers across nodes with scaling and self-healing, almost like managing an entire railway network rather than one train. You can use Kubernetes without Kubeflow, but then you must build ML components, training operators, experiment tracking, pipeline orchestration from scratch. Managed platforms like Vertex or SageMaker solve similar problems, but trade control for convenience. Scaling uses the horizontal pod autoscaler, which reacts to CPU and memory by default, but requires external metrics for GPU utilization, similar to how a restaurant adds cooks when orders spike, but only if someone counts the orders. A Kubeflow pipeline is a containerized DAG, where each step is packaged as its own container, simple, reproducible, and versioned. A common mistake is assuming GPU compute is always the bottleneck. In many clusters, data movement, networking, or storage throughput dominate. In an interview, a strong answer is Kubernetes scales containers. Kubeflow structures ML workflows. A likely follow-up is why combine them, and you can say, it gives you reproducibility, portability, and control at every stage. You're thinking like a platform engineer now, and that's a powerful shift. Key takeaways for your interview. Here's the key idea to carry with confidence. Kubernetes provides the underlying orchestration fabric, placement, scaling, health checks, reconciliation, so workloads remain stable and portable across clouds. Kubeflow extends Kubernetes with ML-specific CRDs that define distributed training jobs, DAG-based pipelines, tuning workflows, and model-serving systems. This pairing shines when running multi-node GPU training, coordinating pre-processing DAGs, or managing model versions in hybrid cloud setups. Kubeflow doesn't perform training automatically. Everything still runs inside containers you create. A common mistake is assuming Kubeflow includes deep model monitoring, but most teams integrate external tools like Prometheus, Grafana, or custom dashboards. In an interview, a strong answer is Kubeflow extends Kubernetes with ML job types, making AI workflows reproducible and cloud portable. A likely follow-up is when not to use Kubeflow, and a good reply is for small single machine workloads, it can be overkill. Don't worry if this feels layered. With practice, these abstraction boundaries become second nature. You're now thinking in the same structure used by teams at LinkedIn, Meta, and OpenAI. Great work. Great job learning today. If this helped you feel clearer or more confident for your AI or ML interviews, tap like so more learners can find you. If you want simple guidance for every interview topic, subscribe so you never miss the next lesson. You can share your questions in the comments. I read them, and they help me choose what to teach next. And if you know someone preparing for interviews, feel free to share this with them. Keep going. You're improving with every step. I'm here to help you grow.